Hello everybody, in this video I would like to show you how to use law of cosines in competition math. So here we go. In order to do it, we need a triangle, and I'm going to draw a triangle, any random triangle. It should be labeled properly. So I'm going to call this as capital A, capital B, and capital C. And of course the opposite side to those vertex is going to be small b and small a and small c. All right, so without loss of generality, I'm going to drop the perpendicular foot from A to BC, and I would like to call this as C times cosine B. So we get A equals C times cosine B plus B times cosine C. B times cosine C. You're currently looking at the first law of cosine. And because that was, true by without loss of generality, I would like to say B equals A times cosine C plus C times cosine A. And you can also check that C equals A times cosine B plus B times cosine A. All right, so imagine multiplying the right side and the left side, both of them, by A and B and C all together. So if I multiply A, well, you've noticed that that becomes A squared equals A times C cosine B plus AB cosine C. And at the same time, that becomes B squared equals AB cosine C plus BC cosine A. And what do you know about the last one? Well, C squared is supposed to be just AC cosine B plus BC cosine A. All right, so let's see what happens. Just like vertically, if you're adding A squared by B squared, what am I having? Well, A squared and B squared just equals AC cosine B, and there's AB cosine C, AB cosine C, and BC cosine A. And I would like to think about some kind of relationship between C squared. Now you can check that there's a C squared, that's AC cosine B. Let me erase AC cosine B. And there's BC cosine A, but there's remaining two terms. So let me erase those two AB cosine C. Okay, so plus, right? So what do we have? A squared plus B squared minus 2AB cosine C equals C squared, and this shall be the second law of cosine.